have to set the conditions of time and temperature. As I mentioned, these are the two variables, right? The pressure is already set. Whenever you hit start the process, the system is going to pressurize with this membrane, right? Basically apply pressure from the top. This membrane inflates, right? And push the plates down, right?
Okay.
So, and applies, I think, around 500 or so millimeters of mercury, or whatever, 0.05 megapascals, but it's always the same. Usually the system goes all the way here, and that's what the pressure applies. So it's important to know that this system, well, it's good to wear gloves whenever you touch stuff so that you breathe.
Okay.
That makes this tool has a bunch of videos in YouTube and stuff about the tool that you can always check later. Yeah, so I will point you to that YouTube channel. Anyways, so again, first step, turning it on. This thing, right, is called counter mold. This thing that looks like a mirror, it's a little bit dirty. You can always clean it. Usually this thing is always cleaned with IPA, right? Isopropanol. That's what you use to clean this, or you use a little bit of IPA, of course, in the chemical hood, and then you blow dry it with nitrogen, and that's okay, right? But assuming this is clean, which is better, I mean, it's not too bad, but
we don't use any wiping, is the name?
Wipe?
Yeah, wipe.
Yeah, with a little bit of IPA, you can use it, but right now it's not going to clear anything because you need a little bit of, you know, like alcohol to clean it. So you can put a little bit of alcohol, clean it. Again, you don't have to do it every single time, just when you notice like it's getting super dirty, right? Okay. So you can put this counter mold, which is the name, either in this position or in this position, really doesn't matter, it's just a counter mold. Anyways, so this thing has like, it's a very simple system. It has, you know, it's two plates basically. Again, this guy inflates and applies temperature and pressure, and it just push everything down, right?
Yeah.
So these things are called spacers, right? These are spacers. Basically just give like what is the maximum height that, you know, physical height is just basically like a stopper, right? Would be of the plate. So right now, because of what we're trying right now, I'm doing some stuff, so this tends to come off, so you can put it back in place if you want, but it really is just to keep like the plate attached, but it really doesn't do anything. It's just like a holder. This thing here, so if it comes out, it's not a big deal, because at the end of the day what you want is to have like the plate completely parallel to the surface. So of course, if you're going to apply the pressure, you want to apply pressure evenly, right? So you don't want this to be like crooked, right? So you want this to be as straight as possible, like parallel. So these spacers, right, are holding this. That's why I cannot push it further, because this is the maximum it can go, right? So for the way we do our chips right now, we are using a smaller spacers. Like right now I'm trying these other things. So excuse me here. We have all the spacers here. These are punch, and these are punch. Where are the spacers? There's also a manual here of the machine. So I mean, the manual is not super like thorough, but it gives you a very good idea of how it works. But you can always read it. And then where are these spacers? Are there or not? Okay, so this one, the punches shouldn't be here. It's just people should be in their own bag. But yeah, since people use this machine, sometimes it's not, things are not in the place that they're supposed to be. But yeah, in this bag we keep the punches, which for your case doesn't really, you don't need them, because it's just to make holes through the chips. but you're not going to do a chip, you're going to do a membrane. So the holes have to come out already from the process. So here you can find different types of spacers, right? Which are a combination of washers, right? Washers are these things, or in Spanish, arandela. And these are the spacers, right? Espaciadores. So point being, these guys, we have different sizes and heights, like 8 millimeters height spacers, 1 millimeter height washer, right? And I mean, this is a die.
Another one.
Yeah, thank you. So, you know, again, in principle,
Yep.
whatever it says here, that should be the height, right? 12 millimeters, that's the height.
Okay.
But again, because people is people, right? And sometimes people put things where it's I will always use a caliper, right?
Okay.
Just to verify the height if
that
you're
is
not
the real
sure.
height.
Yeah. And
But
calipers,
this height you need to plus with this other height.
not necessarily, right? I mean, right now, I have it like that because this is just like, say, you know, say I want to apply a height of, I don't know, 13,
Okay,
right?
yeah.
But I don't have a 1 millimeter spacer, so I used a washer of 1 millimeter plus this to get 13, you know?
Yeah.
So basically,
Okay.
it's just like to get the height I need. These are just to make minor adjustments if you want to think about it, and the spacer. So it really, both of them exactly do the same thing. It's just to give you height. So you can do any combinations of washers and spacers to get to the final height. There might be a case in which you just need one spacer and you don't need any washer, right? Because if you want a space of 8 millimeters, then you're good. You just use 8 millimeters. So you see the point? Like,
Yeah,
that's why it's in 4 corners, because you want it to have even. So you just, you know, attach it manually, and that's it. If you want to measure, gauges are here, like here are all the calipers, and you know how to use this system.
Okay.
And again, because we are doing a different process, I need a super tall thing. But again, in your process is different because you have a really thin film, right? So you need to make sure that your mold, which is a bunch of posts, makes the proper contact with your
Membrane.
sheet of membrane, your membrane, so it heats up, it pressurizes, and you can actually hit the surface and make this. So here, right now, the ones that you're going to be working are the ones that says 0 microns. That means there's no pores.
Yeah.
Right?
Yeah.
So the idea is to grab one of these of no pores and create some pores in a deterministic manner.
Of course.
By the way, I don't know if we have enough of this. So, I don't know. Yeah, we have more. See? All of these are. But this is polycarbonate and this is PET. So, I mean, the ones we currently use are PET.
PET. Okay.
But again, if if the polycarbonate works, use polycarbonate.
We can use polycarbonate.
Yeah. I mean, these two materials are good for our process. I mean, for our cells, they are cell-friendly. So you can use either of us. I will suggest you to start with PET because that's what we already use. But if, say, when you read literature, you find out that, I don't know, people do more polycarbonate because it's easier, because the temperature is lower or something, then we can always adjust to the material, right? So as long as we have deterministic pores, I really don't care if it's PET, polycarbonate, polystyrene, whatever, as long as it's self-friendly. So basically, yeah, so that's how it works. And yeah, so I will continue with this later. Just give me 5 minutes, I'll be back. I remember I have to do something.
Okay.
But in the meantime, you can read this to get all the steps of the thing, so you have an idea. The whole point is, I mean, I should throw this. Remember, we just, whatever gloves we use, no matter what, how we use it, we just throw it in the bins that has like a red plastic bag, right? Again, This is fine, it just doesn't have anything, but it's just a possibility about that. Anyways, so going back to what we were. So, as you know, so this basically it's the whole chamber gets heated at whatever temperature we placed, and then this membrane inflates and applies pressure. So one of the things is like, it's very important for us to know, I mean, this can be changed again based on whatever is your findings. I just did this mold. What is this one? Yeah. This mold, right, that has like different designs, right? I mean, all of these are a series of arrays of posts, and they have different spacings and different diameters. So the ones here are 1 millimeter, right? 1 micron, sorry, of diameter up to 8 microns. So all of this is like a gradient of posts, and the reason why I did it like this is because I want to test how far, what is the smallest post like this system can do, right? That doesn't mean that you have to do 1 micron post. Yeah, it would be great if you can go down to 1 micron, but not necessarily, because we don't know if this system is capable. What we at least need is to be able to do posts of, I don't know, 8 microns, 6 microns, 5 microns, 3 microns, whatever, right? So even if you get some posts from this, from the middle of this wafer to here, which are around 4 microns upwards to 8, that would be great. If it can go down to 1, which I think it could be possible, then that would be great. And again, if this breaks, it's not a big deal. We can always make a new one. Of course, be careful, but because we don't want to be doing one of these every week. But if it happens, right, it's okay. It's not the end of the world. So the thing is, like, once this guy gets heated, right, according to this, I don't know if it's clear, because this manual is terrible, honestly. I had a lot of discussions with the company of how terrible this is written, and they say that basically they apologize and said
They make the equipment, but they don't know how to make the manual.
Yeah, no, exactly. Like there are some steps here that are not correct, which I learned the hard way. But that's always the case with startups. This is a startup company, so they have a lot of flaws in their process. So I had to do my own process and optimize it. But there's a couple of steps here that are not needed. But don't worry. But overall, it makes sense. I will just follow this. This is a protection sheet, right?
Okay.
So that usually goes here on the top. So whatever, the wafer usually goes here, like facing down,
okay.
right? So this just goes here,
Yeah.
just to prevent this guy to, be in direct contact with the plate, because it can, break it, or if there's some material, I mean, because normally they use like some polymers, and the polymers can go on the top, right, when it's squeezed. Some of the surplus material gets here and then gets stuck. So to prevent that, they put this, right?
Excellent.
So it's just like to prevent it. So anyways, the way this usually works, again, you can try the opposite way, right? Again, I'm not limiting you, but how the manufacturer recommends it is you have your mold here. You, like when we are doing chips, this is the material. This is called FlexCoin. It's a special type of polymer made of polycarbonate and polystyrene. It's a block copolymer. It really doesn't matter for us. It's just a compliant material, that it's a thermoplastic, so hence it deforms with temperature and pressure, right? But then when I want to make, again, this is just natural to think, because it is a material that deforms with temperature, that you need some sort of way to make say the PET, and with this PET thing, I will tell you, just because we don't have enough, we can order more for sure. But that will take some time to arrive. Let me bring here's some scissors. Just the piece that you need, right? So we don't waste a lot of material. I'm just searching for some scissors. They are not. So we have here in the lab, as you can see, everything is, you can pretty much get micrometer, all of these things, and they're usually right. So principle, if it says scissors here, you should always open and find scissors here, right?
Sorry. Okay.
So all of the stuff, same PDMS, adhesives, mean scotch tape, these sort of things. I mean, usually the drawers in this lab are properly labeled, and if people follow the things, they should be in the right place. So again, sometimes that doesn't happen, but in principle, most of the times it does. So you can get a pair of scissors. So then say this is the one, right? Again, I'm doing this not very cautiously because this is just a dry run. So say you want this piece, right, of 0 microns thing, right? Again, I think we need to order more, but anyways, so this is the material we want to make holes. So as you can see, is this the one? What happened here?
Yes, what happened? Don't have that
Before
few minutes ago.
What happened?
I don't know.
The hell? No. I don't know. Maybe it's just like it's very interesting. So it's not very. What happened? It was not like. Yeah, I don't know, but I might need to make a new one of this. But anyways, so just to give you an idea, right? So you want this is flat, right?
Yeah.
And then go down. But of course, if you just put it like this down, then you won't have like proper contact. So it's a good idea to use some sort of material that deforms so you can push it, right? Because these posts, the height is only 50 microns. They are super, shallow. So you want to make sure that the actual post gets in proper contact with this. So again, this is just a dry run. I don't know, it won't work. We need to test different conditions. So I will just, have like a little piece here. And then again, this is just to provide some sort of good contact to the thing. And you can try different thickness. As you can see, we have, this one is of 2000, so it's quite thick. But we have ones of 250 microns of thickness.
Okay.
So, this comes with 2 liners, one on the bottom. So you can just place the liner here, right? And try to remove all the bubbles that you can, right? So it's as flat as possible. This is just like when you're wrapping some notebook with adhesive like film. And then again, you take the liner on the top.
Okay, right.
You can keep these liners because sometimes they're useful to, after the things are done, if you say you want to reuse this one, say it doesn't get too deformed,
nice.
then you just, to keep it clean, right, you can use it again. Man, this is
we don't know what happened there.
Yeah. And then here, right, then this guy goes kind of here, right? And then just put it there to have like some sort of contact.
Okay.
Again. And then remember to put this liner, right? It's just for protection. Now, if I were to use these spacers, they are super tall.
Yeah,
There's
don't
no
worry,
pressure,
happen
right?
nothing.
Yeah, exactly. So we have to find like the proper, height. Therefore, we have, a way to push it so they get into contact and they, the post kind of deform the plastic, right? But if they don't have contact, then that's not going to happen, obviously. Just, let's try to keep them in place. And again, this is just an idea, but I was reading in one of the papers that people sometimes machine their molds with metal, and they make like pointy, instead of using like actual posts like cylinders, they use like cone with, you know, like
Oh yeah.
like a
Mm-hmm.
cone. So that might be something you want to read about and think about, because it makes sense, right? If you have a pointy edge, maybe it's easier,
Mm-hmm.
right? That sort of thing, and we can find ways to fabricate those sort of molds or send them out or something. So now the question is, okay, what sort of spacer do we have? And I think the smallest one we have is 1 micron, 1 millimeter, sorry, or 5 millimeters. I think 5 millimeters is the smallest one, and I'm not so sure that, I think honestly that if I were to use I'm not so sure that these spacers will help, because if you think, and this is not good. So for instance, if I put this and I use the smallest one, I don't think we're going to have like the proper contact, right? Even if I just use this, the 5 millimeter, because this is the smallest ones we have, you see, this is still like taller than this, right?
Yep.
So yeah, we might need to use another type of spacers and find out, or we can try it as it is and see how it goes, which is what we're going to do, right? Another thing, right? PET, we have to find out what is like the melting point of PET, right? To know more or less what sort of range of temperatures at least we need. We might need more, right? Because there are more things into the thing. These pins are just for alignment, so it helps you to put it into place
Mm-hmm.
and make sure that there's like proper contact, right? Of this guy. See that it's there. Let's see. And then you just close it and make sure that it clicks, right?
Yeah.
Otherwise, right, you open it like this, and you do this, is not, you just have to make sure that do this click so it's completely closed. Another way to know that it's not closed is like once you turn on the process, it's not building up pressure, means like the pressure is escaping, so it's not properly closed. You can use these heat gloves because once this is done, it's going to be very hot, so use this
Okay.
so you don't burn yourself. um, and then let's check, can you Google what is the PET